We're given some radioactive substance, carbon-14, and it decays such that the amount remaining after T years is given by the equation M of T, that's the mass of this material, that's the amount remaining. Mass at time T, M of T, is equal to a constant 3.6 times the natural number E raised to the negative 1.21 times 10 to the negative 4 power times T. The exponent also includes times T. You'll notice there's a negative exponent. Whenever there's a negative exponent on a base in these types of application problems, it means that we have decay instead of growth. Okay, so stuff is getting smaller instead of growing larger. We're going to find part A, the amount of the mass at the beginning of the experiment when time T is equal to 0. And then part B, the amount of mass that is remaining after 9,833 years. So we're going to take this material, carbon-14, and we're going to work out the amount of mass beginning when time is equal to 0. So we do that by letting T equal 0. So M of T in the formula is equal to the 3.6 times the number E raised to the negative 1.21 times 10 to the negative 4 times the 0 for T. So that means our exponent is simply 0 when we multiply it by 0. So we got e to the 0. Okay, what is any base raised to the 0 power, guys? It's equal to 1. So we've got 3.6 times the number 1, which is 3.6. And this is in grams, by the way. I should have mentioned that. So there are 3.6 grams at the beginning of this experiment. 3.6 grams of this material. Okay, now let's see how much material is left after 9,833 years. We take the same formula in the cloud and we let T, time, equal 9,833 years. So that's equal to 3.6 times the natural number E raised to the negative 1.21 times 10 to the negative 4 times 9,833. Run this through your calculator, and that gives us, now remember, we started with 3.6 grams of this material that they call carbon-14. We started with only 3.6 grams of it, and almost 10,000 years later, actually 9,833 years later, you know how much is left? From that 3.6 grams, 1.1 grams. 1.1 grams left. And we're finished.